Okay, let's look at one last example, and then let's talk through a couple quick problems. So, we are solving for our time dilation here, and we have this equation. Now, something that's interesting about this equation is, let's look at the units before we dive into it. V is a velocity, which is in meters per second. And c is also a velocity, it's the speed of light in meters per second. So if I take meters per second squared and I divide that by meters per second squared, they're going to cancel out. Just like how newtons over newtons are going to cancel, even newton squared over newton squared is going to cancel. And so we won't have any units here. And then our 1 is unitless, so on the bottom of our fraction we don't have any units. And so as far as units go, we're only focused on this t, which is time in seconds. So our final answer will be t, time in seconds. Okay. So then what I did from there was I plugged in all my known values. And let me show you how I ran this on my calculator. Okay. Okay. So I'm going to start by just focusing here inside of my my square root. Now I want you to be aware that you can break this up as much as you need to get all the steps in order to make sure that you don't put a parentheses in the wrong place. I'm going to show you how I would go about doing it on my calculator, and then just see if you end up with the same value. Okay, so I'm going to start with getting my square root, and now on the top of my square root, so I have 1, and then I'm going to go minus, and I want this 1 to be minus from the whole fraction there, so I'm going to put a parentheses for that whole fraction. And now I'm going to put a parentheses which my squared value is going to reside in. Okay, and then I'm going to put a parentheses for this scientific notation. And so I have 2.3 times by 10 to the 7th, and that's going to be squared. Okay, and so there's the top of my fraction. Now I'm going to divide by the bottom of the fraction, and I want my squared value again. Okay, so we're going to have 3.0 times by 10 to the 8th. There's my scientific notation. There's my squared. There's the bottom of the fraction. There's my parentheses. Let's see, bottom of the fraction, parentheses for the whole fraction itself, and then finally square root. Okay. Now, I love pretty print. I suggest getting a calculator that does pretty print, because now I know with all those parentheses that I threw in that I put them in the right spot, because it does in fact work out to what I had here. Okay, so I have my answer of 0.997. And so now I've figured out the bottom. Let's take 5 divided by that value. Okay, so 5 divided by this, which gives us 5.01. But what about sig figs? Well, we have 2 sig figs, 2 sig figs. We only have 1 sig fig. Man, that's not a very precise answer, and so our precise value. It's not a very precise measurement, and so our final answer is not very precise either. We rounded that to 1 significant figure, which this is what I find so interesting. The precision for this example actually resulted in us having this component lost due to the lack of precision. Okay? And then we had seconds like we were talking about before. All right, now the bottom part of this, what you're doing here is through a numerical analysis as well as a unit analysis, you're going to prove that this does in fact equal that. So like here on this, we'd say 6 divided by 3 equals 2. Okay, so that part of it is good. And when we look at the units, we're going to take a Newton and we are going to divide that by meters per second squared. Now a reminder, Newton is a kilogram meter per second squared. And now we're going to divide that. We're going to divide that by meters over second squared. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So we're going to multiply by that reciprocal. Meters cancel, second squared cancel, and I am in fact left with kilograms. I want you to try number 2 on your own. Show us that this does, in fact, equal that. Okay. Don't overthink it. Where have you seen those values before? Is it already a derived unit? Now let's do number 3 together. Remember, I told you, we can only add values that have the same unit. So let's make sure first that a joule over meters is in fact a Newton. Okay, so a joule is, from that table there, a Newton meter. And now we're going to, let me just be clear in my writing here, a joule is a Newton meter. And we're going to take a Newton meter, this joules, divided by meters. Divide that by meters. So the meters cancel and I am in fact left with newtons. So a Newton value plus a Newton value plus a Newton value just leaves me with a Newton value. So on the top of my fraction I have newtons and I'm dividing by kilograms. Well, Newton is a derived unit. So let's take that derived unit, kilogram meter per second squared. And we're going to divide that by kilogram, which is the same as multiplying by the reciprocal. Kilograms cancel, and I'm left with meters per second squared. Now numerically, check if that works out. Do you in fact end up with 14? All right, everyone. So, let me know if you have any questions. Unit exam's coming up, so make sure you're clear with all the information. Okay, talk to you all soon.